Hey guys, welcome to another one of my videos where I use exposure therapy to help treat my choking phobia. So what I'm going to do today is have some poutine, and so I'll first rate my anxiety on a scale of 0 to 100. Of choking, it's 0, and so that's really good. And so this is where you want to get to. You want to get to this point. So the next thing you do is you eat the food. I'm telling you this evidence-based exposure therapy does work because over a long period of time, it took about a year, you see dramatic decreases in the levels of your anxiety. I'm at a 0 right now. Usually though, not usually, I mean, when I first started my exposures, my anxiety levels were at like 70, 80, right? And through exposure therapy, through documenting your levels before and after, and writing down your thoughts also, that's what I found simultaneously helped. So I'm going to finish the rest of my poutine, and I'm going to turn the camera over, and we're going to learn more about anxiety disorders. And I've talked a lot about exposure therapy. I think I've talked about exposure therapy so much that I've pretty much watched almost every video that I think I can about exposure therapy. There are other videos, it's just that I've watched so many and it's been such a long time since I've been doing it regularly that, I mean, I still can. It's just, let's see, because I was going to watch a video about anxiety. What I'm going to do though is look to see which exposure therapy videos have I not watched, because it's YouTube. I'm sure they're coming out with new ones all the time. It's just, there's so many that I've watched, and I don't know, like, I kind of sometimes don't like some because they're like pop therapy, psychological pop therapy, which isn't really evidence-based. It's more just like, it's more drama, it's more dramatic, it's making it all dramatic about the anxiety you have, and oh, this person has this odd phobia, so let's all, like, you know, look at her. And that's not what I'm trying to do. I'm trying to break the stigma. So I mean, a good place to start is Katie Morton. I recommend her on YouTube. She's really good. She talks about a lot of therapy. So, you know, why not start with her? And I'm pretty sure this video has already been, you know, I've done. It's just, I want to start something. And I think anxiety is good as well. I mean, I recommend Katie Morton. It's just, all right, let's try this. Let's try this. I don't think I've done this video. So it's entitled The Anxious Brain, The Neuroscience of Phobias. So I'm just gonna turn this around and make sure you guys can see it. And I'll just listen to it. And then I'll comment on it afterwards. I'm not really gonna take notes or anything. I'm just gonna comment on anything that, you know. I think taking notes is a smart thing to do. Okay, here we go. Oh, no voice. As you can see, this is really
Ledoux, the Henry and Lucy Moses Professor of Science at New York University Center.
This is really professional. This is more for me than it is for you guys, even though I know I'm doing it for you guys as well, because I want to break the stigma of mental illness, wherever it is, and help people with exposure therapy. So here we go.
For neuroscience and Professor of Psychiatry and Child and Adolescent Psychiatry. Okay. At the New York NYU's Langone Medical School. His book, amply titled Anxious, received the 2016 William James Book Award from the American Psychological Association. I'm happy to say he's a fellow of AAAS and a member of the National Academies, but he's also the lead singer and songwriter in the rock band The Amygdaloids. True. This is quite an interesting merger, if you will, of personal and professional interest. I did not ask him if his slides were to a certain soundtrack, but we'll find that out soon enough. So please join me in welcoming Dr. Leduc. Thank you. I should have brought one of the Amygdaloids videos called Fearing, which is appropriate. You can see it on YouTube, though. It's basically based on an Emily Dickinson poem about her problems with fear and anxiety. But today, what I'm going to be talking about is what's going on in the brain with fear and anxiety. And, I was just reminded sitting here that the last time I was here was also around Halloween and was to record something for a Halloween program. So I must be on the Halloween list in this organization. So you probably have heard a lot about the brain mechanisms of fear, and probably have heard that the amygdala is an important part of the brain's fear center, an important part of the brain's fear system, how it makes fear. But what I'm here to tell you tonight is that that's wrong. I can figure out how to advance this slide. Our ability to understand the brain is only as good as our understanding of what we're asking of the brain when we study it. We've made a lot of progress in developing techniques for studying the brain. We can measure genes, we can manipulate genes and neural circuits in incredibly precise ways. But if we don't know what we're studying when we do that, if we don't have a good conception of what we're studying, we're not going to find what we're looking for. This is especially problematic in areas where basic science findings like those that I generate are used to try to understand and treat clinical problems. A lot of what I'll be talking about tonight is from my book Anxious, but also from an article that Danny Pine, the second speaker, and I wrote and recently published in the past few weeks. And so it's good that we're here. We can be a kind of tag team promoting our particular point of view on all of this. So, the words we use to talk about things are important. They underlie the way we conceptualize and think about problems, how we communicate with other scientists, and how we communicate with the public, which we're doing here tonight. So we need to be clear about what we mean when we use a certain word, like fear. And for many years, more than 30 years, I've studied something called Pavlovian fear conditioning in rats. I've done a little bit of work on humans as well, but primarily I've worked on rats. And over the years, I began to be uncomfortable with this designation, fear conditioning. How can we really know what a rat is experiencing? And many people who also study this same paradigm will say, well, we're not really studying fear in the subjective sense. But as I'll try to convince you, that is what most people think you mean when you say fear. So we need to be a little more precise about what we're studying. But this paradigm has been incredibly successful. We've learned a lot about the behavior here on the left. I'm pushing, but it's not doing it. It's all right. I can get over that. Learned a lot about the behavior, about the neural circuits involved, about the cellular molecular mechanisms and certain synapses in the amygdala that are involved with all of this. That's the amygdala sitting in the center there. So it's a key part of this fear conditioning system. And it's been tremendously successful, not only in basic science, but also been used to study a variety of psychiatric problems. Trait anxiety, panic disorder, PTSD, psychopathy, criminal behavior, psychiatric symptoms in active duty Marines, early life vulnerability to psychiatric problems, and of course phobias that aren't on this slide but are an important part of this. And the idea that's emerged is that the amygdala is a fear center. So that a threat comes into the brain, it's processed by a sensory system, it generates a fear state in the amygdala, and that fear state drives the responses. Defensive behaviors like freezing in rats, people will freeze also when a sudden danger occurs. And physiological responses that support all of this. Increases in blood pressure and heart rate, release of stress hormones, and all of these things that are not only in the body, but they feed back and also influence what's going on in the brain. So basically, threat arouses fear in the amygdala, and fear drives the responses. This is based on classic findings. For example, people with brain lesions, people in animal with brain lesions in the amygdala
basically show deficits in responding to threats in this way. So behavioral and physiological responses are impaired. So the idea is that the amygdala activates fear, fear causes the responses, and therefore damage to the amygdala must eliminate the fear. Brain imaging studies, similar thing, when people are exposed to a threat, the amygdala is activated, therefore that fear in the amygdala is what drives the responses when people are exposed to a threat. So it was a big surprise when a few years ago, a woman with amygdala damage was reported to still feel fear. Headlines in Nature, Science, but I'm going to criticize you here for a minute. Scientific American, Wired, Discover. Humans can still feel terror even if they lack the brain's fear center, scaring the fearless, evoking fear in the fearless, on and on. So what's going on here? And why shouldn't this have been a surprise? Well, it's been known for quite a while that threats elicit activity in the amygdala and can produce these bodily responses in healthy people if you use subliminal stimulation techniques. And the people have no awareness of the stimulus and don't feel any fear, and yet they're still responding the way we talk about when we talk about fear responses. People with blind sight do the same thing. These are people who have damage in the right visual cortex, and so they're blind, they're cortically blind in the left side of space. In spite of not being able to report anything on the left side of visual space that occurs there, they can move their hand to an object in that part of space, and if you present a threat in that part of space, it elicits behavioral and physiological responses characteristic of, quote, fear. So you don't need fear, and they don't report feeling fear again. So you don't need the conscious awareness of the threat, and you don't need the conscious feeling of fear in order to respond to a threat. Fear is not what's driving those responses, and fear is not coming out of the amygdala. So this was reported by Liz Phelps, my colleague at NYU, and Adam Anderson in 2002, but it didn't get all the headlines that the 2013 paper did. So, as scientists, we have to we should be paying attention to what's in the literature rather than just running with preconceived ideas and making assumptions, or not even questioning the assumptions that we're working with on a daily basis. So one of the problems is that in our own minds, when we're afraid and we find ourselves running, these things often go together. If you are running from danger, you're feeling afraid while you do that. So it makes sense that the running away should be caused by the fear that you're feeling. It just seems a natural thing. But when we take these things apart in the brain, we see that that's not exactly the case. So what we're doing is committing the first sin that a scientist needs to be aware of, which is not confusing correlation with causation. These events are correlated in our experience, but in our brain, they're caused by different events. Now, as a neuroscientist, I can explain everything about Pavlovian, quote, fear conditioning without using the word fear. The CS, or tone, comes into the lateral nucleus of the amygdala. There it converges with the unconditioned stimulus, or the shock. So the tone and shock come onto single neurons. Plasticity occurs in those neurons. And the next time that tone comes through that circuit, it more easily gets through the circuit because of that plasticity. If you squirt norepinephrine along in this process, the learning occurs a little more efficiently, and the responses are expressed more strongly at a later time. So we don't need fear as a construct to explain any of this behavior. This doesn't mean that fear is an irrelevant construct. It just means that it's not what's causing the rat to freeze when it hears a tone that's been paired with a shock. You can do this kind of conditioning not only in rats, but also in snails and flies and bees and worms. You can even condition protozoa, single-cell organisms. So fear can't be the explanation of why organisms respond to danger. Fear is a psychological process that we build in our brains on the basis of information processing by the highest centers of our brain, which I'll talk about later. So rather than talking about the amygdala as a fear center, we should be talking about it in terms of threat detection and control of defensive behaviors and physiological responses. So what I would like to replace this idea of a fear center with is a defensive survival circuit. circuit that is present in all animals in some form, and that can detect danger and respond to danger. And so this defensive survival circuit will involve the amygdala in mammals and other vertebrates, but in invertebrates they don't have an amygdala, but they have their own circuits. In protozoa, there's no defensive survival circuit because they don't have a nervous system, but they have their own way of doing this. By ion channels and electrical impulses and so forth, they can respond to threats just as we can. Bacteria can respond to threats. So the idea that the reason an organism detects and responds to danger is to make you afraid is ridiculous. This has been around since the first cell has ever existed. It's about survival, it's not about emotions. So this misunderstanding about the difference between threat detection and the feeling of fear and anxiety is widespread. It's built into the conceptual basis of the research, the funding mechanisms, ideas about what underlies uncontrollable feelings of fear and anxiety in the brain, and the use of this research as a way to help treat fearful and anxious people, and the depiction of the work in the media as well. So here's another example. I'm from Louisiana, so I say crawfish. So crawfish treated with a benzodiazepine were more exploratory, less inhibited in a chamber where they received electric shock. This was published in Science as well. Headline, Science said, anxious crayfish may be treated like humans. New York Times, even crawfish get anxious, but the BBC was a little more cautious. Maybe they experience fear and anxiety. So, what's going on? Why does this matter? Well, since the 1980s, billions of dollars and millions of animals have gone into the search for new and better treatments for fear and anxiety. In 2010, the CEO of GlaxoSmithKline concluded that the efforts have failed and new investments wouldn't be made because of the low probability of success. Andrew Holmes, a leading researcher, reached a similar conclusion. These efforts have been disappointing. Promising results with novel agents and rodent studies rarely translated into effectiveness in humans. So what's going on? So these are some various tests that you can use to develop a new drug to treat fear and anxiety and through an animal model. For example, elevated plus maze, top left there, the rat or mouse is put on the open arm of an elevated maze there, where it's unprotected. Rats are prey, so if the rat were in an unprotected area like this, a hawk could swoop down and eat it. Same way in the open field, if it's in an open area, it'll run to the side. In the elevated plus maze, it runs to the enclosed area. So if you give, the idea is that if you give the animal a drug that's going to relieve fear and anxiety in people, it will make the animal move into the safe place less quickly. So the animal will be less timid, and since the behavioral response, timidity, is thought to come out of the same circuit as the experience of fear and anxiety, then measuring timidity in the animal should give us a drug that makes people less fearful or anxious. But this doesn't necessarily always work. In fact, it hasn't worked very well in all these studies that have been attempting to develop new drugs. But it's possible that the drugs are doing exactly what they were designed to do. Maybe a person on a drug like this, say that has social anxiety, might be more willing to go to the party, in other words, less timid, but still feel anxious while there. In other words, the person would not feel that the drug was helpful, but if the drug did in fact do that, it would allow the person to be exposed to the party, to figure out who's safe and who's not safe at the party and so forth, and to kind of self-treat them, self-expose themselves to the threatening cues that way.
Alright, so that was basically some of the video. I finished my exposure. Oh, sorry. And so, the guy, I'm trying to follow what he's saying. I don't really understand what he's saying. I mean, in the beginning he was talking about Pavlovian conditioning. And I know I went to school for that. In high school they taught us, it was a course called Challenge and Change. They taught us, like evolution and psychology together. And in that course, one of the things they taught us about was Pavlovian fear conditioning, which was this idea that dogs would, I guess, get shocked, right? I don't know. No, sorry, dogs. It's not fear conditioning. It was just conditioning. If I remember correctly, it was like, okay, dogs would be like have to be heard a bell, and when they hear this bell, they'll get food, and they'll keep doing this for them for a period of time until they're trained to understand that the bell means food. So then what they did was they started ringing the bell for the dog after he's already been conditioned to associate the bell with food by giving them food every single time. When the bell's being rung, they would ring the bell and not give the dog the food. What they found out though is the dog would actually begin to salivate and would actually have a physical reaction to an external stimuli, or the bell, even without any reward, even without the expected outcome of food. So that is conditioning. And I guess, fear conditioning is kind of like where people who have anxiety disorders participate in avoidance behaviors, or, kind of ways to cheat our anxiety, cheat our way out of things by saying, oh, I'm not going to, eat the harder food, I'm going to eat the softer food, or I'm not really hungry, I can go without this food, I need to lose weight anyway, right? And so that kind of whole idea is, I guess we're talking about conditioning, fear conditioning. You can condition your brain to fear based on, external stimuli. And so if you change your, the underlying assumption of all of this is that your brain has neuroplasticity. So your brain is neuroplastic. It can change its rewiring and its like internal mechanisms. So look at me. Like before, I thought that it would be scare. I would associate food with fear, and I still do associate food with a small degree of fear. What I associate it with more though now is wanting to help others, wanting to be nourished, wanting to face my anxieties, sometimes I don't even associate with anything. It's just something, right? It's just another neutral object in the world, in life. So that's neuroplasticity in a nutshell. The next thing he was talking about was like how, I guess, there's been a huge failure of the anti-anxiety medication industry. How that simply because this is going to get really technical and hard. I don't really understand. I'm not even getting into it because I don't understand it fully. I don't want to confuse you guys. So I'm just going to skip that part. I know it's really important. He's basically just talking about how the anti-anxiety industry has failed because of their approach to dealing with anxiety. Their approach is based on a faulty assumption because they weren't really kept up with the literature. Scientists kind of just went with these assumptions, not really looking into the ongoing progression of science, because science, it's an ongoing progression. Science is something that you're constantly learning in science. Like there's new studies being published every probably day, week, and month about anxiety, about depression, about everything. So if you don't keep up with those studies, you're going to fall into these assumptions. And he says that's what the people have done, and that's why there's a huge failure of anti-anxiety medications. Okay, that's that. The video's done. I don't really think I have anything else to talk about. Yeah. Ooh, one quick thing. I have been realizing and deassociating for a while now. There's very small periods of time. Like I would be doing something, and in the middle of it for about 5 to 15 seconds, I would derealize. I don't know why. I don't know where it's coming from. I mean, like I hallucinate, so perhaps it's my hallucinations confusing me. I'm not sure. It's really complicated. I fear like they're telling me to not go get my hair cut, even though I know I want to get my hair cut, because they're saying basically don't do it because it's bad. And I've convinced myself it's a waste of money. I've also convinced myself though that I want to get it because I don't like how my hair turned out when I got my first haircut. I paid $200 to get my hair straightened, and I don't like how it turned out. I mean, it's not straight. It's more of like a Brazilian blowout than it is a the pinprick Japanese hair straightening I wanted. So I've been kind of thinking, basically, you know, is it good to go? Is it not good to go? And I decided that I want to go as much as I don't want to. That I do want to go. I know it's going to cost some money, some more money. About I think $300. They may have a half price discount, so I don't know. That's kind of pushing me to go as well. And it's just this idea that, you know, why not go and get the hair done straight? Because a couple things. This has to do with anxiety as well. I'm not just ranting about my hair. Because I want to celebrate the reopening of the world, of COVID. And the best way to do that is for me to get a nice haircut. So I can look nice, be nice. And like, you know, it's not like you look nice and therefore you be nice. I mean, it makes you feel good. It makes me feel good. Some say it's self-care, right? Self-care. I don't know. Like, sure, if that works. What I'm saying though, for me, is I enjoy it. I enjoy getting. I hate the process of going there, waiting 3 hours for them to do it all. That's boring as hell and awkward and anxious and whatever. And I believe I can deal with that though, is if I can deal with the tools I have and work on my comp plays and be mindful and, you know, basically do that. What I'm saying though is, the result of getting the haircut and being really nice with it, having a really nice haircut, you know, with pinprick hair, I think it looked really nice. And I just like it. I like to look that way. And you coincide that with the reopening of everything going on in the world, with the reopening of COVID. You know, I think it's a great way to just express myself and to be happy. And I don't think that someone should be, I don't think someone should really be denigrated for that or hated for that. So if you're suffering from hallucinations, try to talk about them, talk them out. They'll get less scary. And simply, you know, be mindful of when you're derealizing, deassociating. What I realized though is sometimes, what I found is a nice coping tool is if you realize you're derealizing or disassociating, like if you feel like you're out of your body, you feel like you just aren't in control, you feel like you're gonna have a panic attack, you feel like just, whoa, what's going on? I don't feel how I was feeling before. I feel like I'm just slowly going out of my body and I'm not really where I want to be. Open up your phone and just record it. Right? Just record it. You don't have to say anything, just record it. Record your anxiety, your derealization for as long as it takes. And I've realized a lot of times that helps a lot as well. Okay. So I'll leave it at that. My anxiety was like a 10, and honestly I wasn't really paying attention to, no, sorry, it was 0, so you can't really, you know, watch it go down. So with that being said, remember guys, stay with it.